But it's really fine because I can't throw it
I'm
in.
actually really impressed with just the 11, like the 10R version. That's a really nice phone. Like they really upgraded it.
Yeah.
So I'm gonna look forward to that one.
I like it.
Why is it that they've come up with that
That is
phone?
Because the camera is this
Well, yeah, I was like, pretty soon the whole back of the phone is gonna be a whole camera.
I think they had a reason.
4 hours per day.
Telephoto, wide, telephoto, wide, super zoom. So those are like your three major cameras that you always have.
Did you?
And what is like one
In the
phone?
right, right with it. All right, we can do that. Yep. Wow. Let's see how it writes.
Telephoto, no, they didn't have
The
one.
answer. Like, no, I
Okay.
did. I have to transfer it. I don't want to do it after.
Okay, I got two problems I'd like to walk through today. Once I'm done, you will have time to work on your homework. It's on the board, page 33.
25 minutes.
I'm gonna give you plenty of time to work on that today. Tomorrow, maybe a little bit of time, probably not as much as today. Today's kind of just intro. I got two basic examples I wanna go through today. So here's my first example. It's kind of like the one we did yesterday, where it's gonna be something like this: 5 to the 2x, or sorry, 2 plus x, and 3e to the 4x. So these are my two parts that we have on this particular problem. This is one that we did very similar to yesterday. I want to at least have this on the board so you can look at it and use it as a reference. The next one I'm going to do is kind of more of a basic story problem kind of a thing. All right, so in this problem, what you're supposed to do is solve for x. Find the exact value of x that would give you the correct digits, the correct terms. Okay, all right, so to do this, you have to take the natural log or log of both sides. I don't really mind which one you do. I'm going to do the natural log because it has e in it. So I'm going to take the natural log of both sides.
Think you're supposed to work it out.
That's a good question.
Okay, questions on our major parts we had. Okay, next, I'm going to drop the power out front. So this 2 plus x is going to drop out front. This 4x is going to drop out front as well. Now here's the problem. Do you agree that there is two things being multiplied right here?
Yes.
Before you drop the power out front. Okay, because I know most people want to drop it. We want to make sure that you separate these two items before you do that, because technically, this is one of the questions I had yesterday, the 4x is only on the e. It's not on the 3. That was, I think, the question we had yesterday. It was a good question. So, you want to separate these first to be this, into their own natural log, because the product rule, when you multiply two things together, you can separate them with plus. Now I can drop the 4x out front. So that's where this can go out front of its own natural log. The 3 won't have it, just the natural log of e in the back would. Okay? On the other side, that 2 plus x drops out front with the natural log of 5. And then what I'm going to do here is I'm going to distribute the natural log of 5 over both. So 2 natural log 5 plus x natural log 5. Questions on the whole setup, what I've done? Now, the next part is I'm going to move all the x's to one side. I don't care which side you go to. I want to move the whole numbers to the other side, or anything that's a digit. And I want to solve for my x. So what I'm going to do is I'm going to move these x's over. I'm going to move this 2 natural log 5 over to this side. That way the x's are on one side and the other numbers on the other. Now, before I move this, what is the natural log of e?
1.
This is a 1, right? Because it's what part you put on an e that makes e, well, it'll be a 1. So that drops out. So this is 1 times 4x. So when I move it over, I'm just going to get rid of that natural log on it. Okay, so here's what we have so far. I've moved everything around and I've got to this point. What you have to do next, factor out the x from both of these. They both have x's in common. I'm going to factor it out. So here's what I have when I factor it. It's natural log of 5 minus 4. On the other side, I'm going to leave that alone. There's really nothing I can do on this side, right? Because there's nothing I need to factor or anything. And then I'm going to divide this over. So my final answer in this particular problem, when I divide, I'm gonna get this. I'm gonna get x equals natural log of 3 minus 2 natural log of 5. And what I'm gonna have here is I'm gonna divide by the natural log of 5 minus 4. This is the exact answer I'm looking for. I do not want a decimal. Don't give me any decimals for that. If you check the back of the book, they will give you a decimal. I don't even want it. I want the exact answer for it. Move to the next problem. I'm gonna leave that on the board. The reason being is that it's probably the most difficult problem you're gonna get in the beginning. Most of them are very simple. You just take the natural log of both sides and it drops and you just solve for x. It's like a super easy problem. It's the ones that make it difficult is when you have to distribute the natural log of 5 over a parenthesis, because then you gotta drag things around. So that's why this makes the problem, because they have binomials in the powers. And they have multiple x's everywhere. Questions on that problem? All right, last problem I want to do is a story problem, where they kind of give you kind of a rough story and they ask you to, find a certain result. So let's say that you had 1,000 grams of a certain substance, and over time, over let's say a 25-year period, over 25 years, it dropped down to 750 grams. What I want to know is how many grams are left? How many grams are left after you go 130 years? Is there anything left? Will there be like a small fraction?
Yeah.
That's what I want to know. I want to know how much is left off of that number. Okay? So we're gonna go through the calculation here. They're expecting that this is exponential decay. I believe they even say it in the instructions above these story problems, like use exponential formula, which if you don't know is this formula right here. It's a equals p e to the rt. That's the formula. I'll leave that on the board. That's the one I use for all story problems if it's exponential decay or growth. This is actually going down, so it is decay. So I'm expecting that my rate will be a negative number because it is getting smaller as I go through the years. Now, plugging my numbers in. I have 1,000 grams. That's my initial amount. I don't know my rate, but I do know it's taking me 25 years to get to 750 grams. That's the amount I'm getting to. Does that make sense? To solve this, I would divide the 1,000 over first. So that's 0.75 e to the 25r. I'm going to take the natural log of both sides, so I can drop the 25 out front. So natural log 0.75. When I take the natural log of this side, the 25r will drop out front. I'm just going to do that all in one motion. The natural log e will make a 1, so that basically goes away. I'm going to divide by the 25. Now this rate that I'm going to get, the natural log is 0.75 and divided by 25. This number is going to be a negative decimal on your screen. It's decaying, so it's got to be negative. Now type that in, just so you know what that decimal is. Natural log of 0.75, and I'm going to divide that by 25. I'm getting negative. Negative 0.011507. Now, it keeps going across the screen, but you guys get the idea. Okay, what I'm going to do with that number now that I know what the decay rate is, I'm going to use that to do the secondary question. How many grams are left after 130 years? Well, that means I'm going to start with my 1,000 grams. I now know my rate is negative 0.011507, blah, 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 but now I'm going for 130 years. I can plug in my time as a different number now. And I can just type that in my calculator, just making sure when you're typing this in, I would actually multiply these two numbers first, figure out what that decimal is, and then put it in the power of e. I would just do that one step at a time. But typing this in, negative 0.011507, that times 130. All right, so this number, this negative number, to in the power of e, taking it times 1,000. Here's the answer I'm getting. I'm getting 25 224.04 grams left over. That's my final answer for that problem. That's putting that e to that power and then taking it times 1,000. So I was going significantly down in terms of grams. It takes 25 years, and it's it's dropping chunks at a time of a certain percent. Questions at all about the types of problems you're going to have today? Now this homework assignment should seem really familiar. It was just like the problems we did on page 17. We did a bunch of logarithms back then, but we never really had to do a lot of calculations. You just had to tell me what the rate was, or what its decay was, or if it's growing. You didn't really have to do a lot of calculations. Okay, turning loose. It is page 33. You have the rest of the time to work. You have more than 20 minutes. You have actually almost 30.
Don't turn me loose.
Wow, that's a long time.
A lot of time for no.
Jacob's already stuck in the person.